We're just going to focus on the vertex form. Where's my pen? All right, step 1, guys. Get a highlighter. This is the key information. The vertex is h comma k. Remember, h is the opposite value. Sorry, it's not up there. So first thing we're going to identify is the h and the k. So I'm going to underline, get just a regular pencil. When I'm referring to the vertex form, it looks like this: y equals a, parentheses, x minus h, close the parentheses, square it, and then plus k. Don't talk while I'm instructing, please. Everyone should have an equal opportunity to get the understanding they need without interruptions. Thank you. Okay. All right. Step 2, we've been doing this, but I just need to make sure you understand to use your table of values correctly. Okay. So in step 2, you're going to make a table of values using the symmetry. Okay. We're going to make a table of values using the symmetry. It says right here, the x coordinates you use should be 2 consecutive numbers to the left and to the right. Okay. 2 consecutive numbers to the left and the right of the vertex. Well, when they were referring to the symmetry, that means that the vertex is in the middle of the table. I'm just going to abbreviate. Yeah, because we want 2 points. We want x coordinates before and after. I'm gonna show it to you on the example. They show where the symmetry is being drawn. Okay, so example 1 they've kind of done for us. I'm just gonna show you the key information of how they set it up. Okay. The first thing I want to just show you is that if I write my vertex form, a parentheses x minus h, that's minus h, close the parentheses squared, plus k. All right, I'm doing that so you can line up your h's and your k, because that's what we need for the vertex. So if you look right here, it says, remember to find the hk, and it says, remember the h is the opposite sign. So h is inside the parentheses right there. And if you look inside the parentheses, there's a plus 2. But when we do opposite of that, the h is a minus 2. Do you see that opposite sign? That relationship? Your k, I'm going to do a different highlighter. The k is outside the parentheses, and the k is going to have the same sign. Okay? Which is the -1. So anytime I take something outside, and I meant to put my, anytime I take something outside the parentheses, I have to do opposite the sign. If it's outside the parentheses, I keep the same sign. Okay. So here's what they're saying. Plot 4 points to make your table of values. They've already done that for us. Okay. So if you look down here, I'm just going to highlight. Here is the vertex. Okay. And right here, it says, notice the symmetry. What they want you to notice is that if I look at my points, this is 2 consecutive after and 2 before. And if I look here, there's 0 and 0. They're the same above and below. Then we have 3 and 3. The same. Oops, I didn't mean to do that in a big. This is showing same here. Okay, do we see the symmetry? Okay, so I'm going to just scroll up just a little bit because they've already graphed the function for us. But I need you to understand when we compare it, we always compare to the parent function. Okay. Yeah, x squared, exactly. So I'm just going to make a note, compare to, did I don't think I did, or did I? I did, okay. Compared to parent function. Here, write this, add this to your notes. Parent function is y equals x squared. Okay. All right. I'm gonna graph that on this grid here. So let me fix my pencil here. The parent function goes to the origin, so I'm gonna put a point here. And if my x is 1, the y value is 1, because 1 squared is 1. If I made my x 2, that would be 4. 2 squared is 4. 1. Now notice what I'm doing. I'm just doing the first 2 points. Remember, we're doing consecutive points before and after. But as long as I know 2, they're going to get reflected. I can see that this point is 1 unit away from that y-axis. So 1 to the right means I got to go 1 to the left. I reflected that point. Pay attention, guys. This point here is 2 units away from the axis of symmetry. Since I counted 2 to the right, I just got to go 2 to the left and plot that point. So I'm just going to sketch a line through these points to make the parent function. Okay. All right, so our first question in our table for our parabola, the black one, is the orientation. Does it open up or down? Yeah, so we got check off up. Is the vertex location a max or a minimum? It is a minimum. So then it says list the order pair. So I'm going to put a point right here. I'm going to draw an arrow pointing to that point so I can label it the vertex. And that order pair, -2, -1. Yes, I'm going to put that on the graph and I'm going to put it in the table. Do both, please. Your axis of symmetry, that is the vertical line that cuts the parabola in half and goes through that vertex. X equals -2, yes. I'm going to draw an arrow pointing to that dotted line, label that the axis of symmetry. I can abbreviate that. This is what I did on the Ed puzzle as AOS. Okay, add that to your table, please. AOS. Okay, so vertical stretch versus shrink. Okay, guys, so I'm going to show you something real quick. I need your eyes on the board. And I just want to first talk about stretch and shrink. Just because these are talking about the size of the graph, the U shape. Okay, so if you look right here. Okay, there is the parent function. Okay, this is vertex form. Right now, I'm going to just talk about, make sure you understand our graph of our new function shifted to the, oops, I'm going to make that the same, sorry. Okay, H, it shifted to the left to right. I got to get over. There we go. And it went down 1. So it's like right there. Are we okay on that? Now, did we see that the shape, I didn't do anything to the shape. It's staying the same. Even though I'm moving it to the left and down, the shape is still going to be the same. Like if I go back to where I was, so there is 1. Oh, I mean to go 0. Sorry, there's 0. If I go back to the origin, there it is, and then right there. See, it stays the same shape. Are we okay on that? Okay, so on our table here, if it doesn't stretch or shrink, neither, then it's going to stay the same as the parent. So these two go together. All right. Did you check that off? Are we okay on that part? Okay, so our domain is always all real numbers whenever we have arrows pointing up like we do here. Okay, that means it's continuously going. But our range corresponds with the minimum. If I have a minimum, it's greater than equal to min. So this would mean that y is greater than or equal to -1. When we're looking for the minimum value, we're trying to see where on the y-axis, how low did it go? And it was a -1 right there. And then our y-intercept, we should physically see it touch. I'm going to put a point, make it bold, where it touches the y-axis. That is the y-intercept. That is at the point 0, 3. Okay. So here's what we need you to recognize in vertex form. This original parent function, if I just focus on the vertex, where my pen is at, it shifted to the left down, to the left here, and then it went down. So I'm just going to draw an arrow. It went from this direction here first, then it went down. So the transformation from the parent, add this to the bottom of your graph, please, is that it is a horizontal, and I'm just going to abbreviate horizontal, shift to the left 2 units. And it's going to be a vertical shift. I'm going to abbreviate that. It is going to be a vertical shift down 1 unit. So if you want to kind of just give the orientation, that means I'm drawing an arrow to the left, and then I could put 2. That means it went to the left 2. And then I can draw an arrow pointing down and put a 1. That means it went down 1. Okay. All right, so let's look at this example we're going to do together. Look at number 1. Add to your paper the vertex form, which is a parentheses x minus h, close the parentheses square plus k. Okay. So we're going to compare this to the parent function. And in order to do that, we're going to have to create a table here to the left, x, y. Oh, sorry. And we can type this equation in the calculator. If you go to y equals, mine is already in there. Yours might be in there too. I put the parent function at x squared. Guys, notice this. My parent function is going to be blue on my graph, and then the new function, the transformation, the vertex form is red. Okay? We can physically see how it changed. So I did y equals x squared for 1, and then x minus 1 parentheses squared plus 2. All right, so yes, we saw that it opens up. Is our equation a max or min? Okay, where is that minimum? If I'm looking at the graph, where is the lowest does my red graph go? 2. No, that's the point. That's the vertex. That's not the minimum value. What's the smallest value? Not a point. What 2 is the smallest value of the graph. Yes, because from here it gets bigger than 2, right? So I'm just saying that because you need to make sure that the minimum value is at 2. All right. Remember, to do the vertex, this is when we're doing h, comma, k. All right. The h has to be opposite the sign. So what is the h value here? +1, not -1, right? So it's +1, and the k value is the same sign. What's the k value here? Yeah, so it's 1, 2. That 1, 2 has to be in the middle of your table. and you're going to have consecutive points going after the 1. So that would be 2 and then 3. Consecutive points before the 1. That would be 0, -1. So we're going to plot that vertex at 1, 2. Oh, sorry, I didn't go up enough. That's going to help me see my axis of symmetry. Our axis of symmetry should be x equals 1. All right, now we need to go to our table and see the pattern with the points. If I go second graph, I have to look at the red table for me because that was the second graph. What is our pattern with our x coordinates after and before? Yeah, it's 3 and 3 and then 6, 6. Y'all see the pattern? Guys, are y'all seeing this? Okay, so fill in our values. We should have 3 and then 6 and then 3 and then 6. So we're plotting those points. So at 2, we should go up 3. And then at 3, we're going up 6. I can just reflect those points. That's 1 away. That's 2 away. And we can sketch the graph. All right, did this graph stretch or shrink? Did the shape change? Yeah, it just went up. Yeah, so it's neither. It did not stretch or shrink, so it stayed the same. What's our domain here? Our real numbers. What's our range going to be since we have a minimum? Very good. Y is greater than or equal to 2. Very good. It's always that smallest, lowest point. Y-intercept is 0, 3. Okay. So I want you, here's the thing I need you to look at real quick, guys. And okay, so remember I talked about the shape doesn't change? Look at this right here. Okay, so H is for horizontal, guys. Look. Horizontal basically shifts it left or right. Are y'all seeing this? Okay, but what you need to understand is if my H, remember I have to do the opposite. So I know this is saying H is 2, but in the equation, it's going to be a -2. Even though I'm going to the right, you have to do the opposite. It's going to be a negative number. Even though I'm going to the left, I know that's negative values right here. Right here, you can see the negative numbers. But the H has to be opposite of that. So that means it's positive. So if H is +5, there it is right there, then it would be here. If H is -3, then it would be over here. Are we okay on what the H does? Oh, it just reverses. Yeah, reverses, yes. Are we okay on that part? Okay, now, the K, all right? The K makes the graph go up or down. Are you seeing that? No. Okay, so if K is positive, it's going up. You see that? That's a +3, 4 right there. If I got a negative, let's say a -2, there it is right there. Okay, are we okay with K? K with K. All right, now, here's what I need you to look. The other one we haven't talked about is the A. That's what's in front of the parentheses. Okay, look, pay attention. Let me go back to the origin. Hold up. Okay, let's go here. Okay, here we go. Here's A. A is 1, a visible 1. Now, if I make A bigger than 1, look what happens to it shrinks. Yeah, it gets skinnier, narrower. This is called a stretch, a vertical stretch to make it shrink. Now, if A is not bigger than 1, but greater than 0, but less than 1, see, it has it stretches wider. This right here would be a fraction. If I have a decimal, okay, there's my decimal, it gets wider. Now, the minute I make A a negative, look what happens. It flips over the x-axis. Do y'all understand that? Okay, so what you're going to do is you're going to finish this problem, okay? This is what we're going to check tomorrow at the beginning of class. All right.